So today we're doing systems of equations again, systems of a quadratic and a linear, just like we did last class, but we're putting them into word problems. Yes. So let me read this first one to you. A rocket is launched from the ground and follows a parabolic path represented by the equation y equals negative x squared plus 10x. At the same time, a flare is launched from a height of 10 feet and follows a straight path represented by the equation y equals negative x plus 10. Using the accompanying set of axes, graph the equations that represent the path of the rocket and the flare, and find the coordinates of the point or points where the paths intersect. So we're not going to graph this like it says we are going to. Instead, I'll quickly just show you just a quick, oh, well, it doesn't show up very well. Show you just a quick little graph of what this would look like. You don't need to draw it. You can just sketch it really quickly. We have an upside down parabola. How do I know it's upside down, by the way? There's a negative in front of the x squared. So I know it's upside down. And then we have this linear line that goes and intersects it twice. So just a quick little graph. Now, because I'm not making you graph this, because it's kind of hard to graph, how else could we find the solution between these two equations? What do we do? What did we do last class to find the intersection points? We have two equations. We want to know when they intersect. What do we do? Yeah, you set them equal and solve. So we have negative x squared plus 10x equals negative x plus 10. We want to find the solution, the intersection point between these two lines. So now that we have them equal, what do?
Get them to one side.
Get everything to one side. Beautiful. So I'm going to add x, and I'm going to subtract 10. So I have negative x squared plus 11x minus 10. Now, we have a negative x squared. What can I do right now?
Make it a positive.
And how do I make it a positive?
You got plus.
No, we already did that.
You gotta add 2 x's, right?
Why didn't we go the other way?
Ah, we probably could have gone the other way and moved everything to the right. Instead of moving everything to the right now, what can I do to get rid of that negative 1 in front? There's multiple things you can do. You can multiply everything by negative 1. You can pull out a GCF of negative 1. These are actually the same thing. These are the same thing. So that's what I'm going to do. I am going to pull out a GCF of negative 1. It becomes positive x squared, negative 11x, and a positive 10. So now, what do I look for? What do I do? Yeah, factor. What goes up top? Which is 10. And in the bottom is negative 11. What multiplies to be 10 but adds to be negative 11? Right. Both being negative. Negative 10 and negative 1. Are these my true factors? Aren't they?
Yes.
What's my A value?
Negative.
That we pulled out to the front. What is the number right in front of the x squared? A positive 1. So do we have an A? No, I don't need to divide by the A value. That's why I pulled the negative out in the beginning, so I don't have to divide by the negative 1. Okay. How do I then take my factors and find solutions?
X.
You set them equal to 0. So we have x minus 10 equals 0 and x minus 1 equals 0. So to get the x by itself, I add 10 over. X equals a positive 10, and I add 1 over. X equals 1. Am I done? What's, yes. Which equation should I plug it back into?
2 parentheses plus 2.
The negative x.
Yeah, the linear line, because it'll be easier. So we have, plugging in our first x, 10. Negative 10 plus 10 is how much? 0. Then we do the exact same thing for the other x we found, 1. Negative 1 plus 10 is how much? 9. So how do I write my two solutions?
10, 0.
10, 0 is my first. And then?
And then 1, 9.
1, 9. Any questions on how we got those two solutions?
I got a question.
Yes.
Why do you put the 10?
Because that's our linear line. Look up here. See this line? Negative x plus 10. I plugged the x back into that equation.
Okay.
That's where the 10 came from. Any other questions? All right. Now I'm going to show you. Did anywhere in this problem, did it say solve algebraically or show all your work? No. So guess what you could actually use? The calculator. Take out your calculator. Take it out. Does anyone know what we can do to find the two intersection points? What do you think our first step is? Go to y equals. And what are you going to do in y equals? Put both of your equations in. So in y, whoa, no, that's not what I wanted. In y1, I'm going to put my first equation, which was negative x squared plus 10.
Which one is the first one? Negative x squared.
Plus 10x. Does it matter which one you put first?
Negative x
Nope.
squared plus 10.
Plus 10x. Then you put your second line, negative x plus 10.
Oh, wait.
Does anyone know what we hit after that? What? Graph, yes. Now,
Oh my god.
if your graph is its standard form, the window doesn't quite show all of the intersections, right? Intersections. So, which ones or how could I change my window?
You gotta
Zoom, what could you do? You could try zoom. Whoops. I would try, well, you could do zoom out, or you could try zoom fit. I'll try zoom out. I don't normally use zoom out that often. Yeah, it didn't help me. Zoom out didn't help me. Let's try it again.
Oh, so, wait, how did you?
No, it's not helping me. So I'm going to try zoom fit, which is 0. See if that helped me. Nope.
No, I just looked.
Jeepers. All right, so I'm actually going to now have to resort to going into my window and changing these numbers. I know that I want my X max to be a little bigger. I'm going to make it 20. And I know I want my Y max to be bigger. I'm going to make it, I don't know, double that, maybe 40. I don't need my Y min to be any bigger.
So, just the graph hiding right after that.
Then you hit graph after that and check it. See if you can't see them. Oh yeah, that's much better.
But we just set them at.
So I knew that I had an intersection point that was a little bit more to the right. So I made my Y max, my X max bigger. I made it 20 because I knew I wanted to see a little bit more to the right. I also knew I wanted to see a little bit more upwards. So I made my Y max bigger as well. So my numbers are negative 1020 and negative 1040. That's what I did. And then I took a look at my graph. And yes, now I can clearly see my two intersection points. Does anyone know how to get those exact points? Does anyone know what you hit? Second, trace, and then what? Intersect? Yes, 5. Now, first curve just means have it be on the first line, which it is. It's on our first line. Go ahead and press enter. Second curve just means it wants it on the second line. Your cursor should automatically jump to the second line. So you just press enter. Guess. Get right on the what? Get right on the point.
Which, any point?
There's 2 intersection points, right?
Yeah.
The one that's to the left and one that's to the right on the x-axis. So I'm doing the left one first. 1, 9. Is that not one of the solutions we got?
Oh, shoot. I don't know if I'm doing it.
Yeah.
Yeah. Then we do it again for the second intersection point. You press second, trace again.
I bet it's 10-0.
Oh, you bet. I bet too. First curve should already be there. Second curve should already be there. Guess. Move your cursor until it's on. I want to just scroll over. Your second intersection point. And press enter. Oh, 10-0. Look at that. So just like that, we have our solutions. You can do this whenever it does not say solve algebraically or show all your algebraic work. Now, can anyone take a guess what our solutions are actually missing? What do you think our solutions are missing? Oh, it actually doesn't give you units. So I guess you don't need to provide them. Oh, it does. No, it does. A height of 10 feet. But it doesn't give you a unit for the x value. So in the future, we'll normally always give you units. We're just going to say that the time is seconds. So this is 10 seconds and 0 feet, and it's 1 second and 9 feet. Normally I would put those right in my coordinate points. I would put parenthesis 10 seconds, comma, 0 feet. Parenthesis 1 second, comma, 9 feet. This will get you full credit on your test. Or you could write it out in a sentence if you like it that way better. Any questions here?
Wait, in the example,
Yeah?
it has negative x squared, and when we switch, we have, I really don't know how to say it, but like, wouldn't we want the negative x squared to be positive?
Yes.
So wouldn't we just put that to the other side?
Yes, that's what we should have done. But I wanted to show you that there was a way to fix it if you forgot to do that. So we just pulled out a -1. But yes, if we were doing this correctly from the very beginning, we could have just moved everything over to the right. Good question. Any other questions? All right, I want you guys to go ahead and try to do number 1. You do not need to graph it. That's just there in case you do want to graph it, which I doubt you do. So go ahead and try to do number 1, just like we did in the calculator a second ago. You don't have to do this algebraically. Try to do it in your calculator. Take a look at number 2 and tell me why it is more difficult.
Because it only has one thing.
It only has one equation. How did we learn last unit? Do we create an equation from points? How do we formulate an equation from points? What do we use?
Oh, I got it. You do the x minus and then put the number and then the parentheses thing.
Well, not quite. So that's factoring. We don't have an equation at all yet, right?
Yeah.
No. So we take these numbers and we multiply?
No. Wait, what's your question?
Okay.
I got this.
How do we take points, which it tells us points in this first part of the equation? How do we take points and find an equation?
Go backwards. Then you set them equal to 0. Oh, the table.
Oh, can't you input points into stat edit and then hit stat calc and get an equation?
Oh.
That's what we're doing here. So the first step is to find the points, right? The first step is to find the points. So, I'll explain, don't worry. First, I want to find our points. It says a cannonball is fired from a height of 45 feet. So I'm not even going to use this real graph. I'm just going to sketch a little graph so I can help find my points. If I'm firing a cannonball from a height of 45 feet, at what time am I firing it?
6:45.
At what? 0 seconds. So if that's 0 seconds and 45 feet, what is the coordinate point there?
Wait, how do you get to the table?
Hold on. First, we're doing this. First, we're going to graph this little tiny graph. Then it says it takes the shape of a parabola. In 3 seconds, it reaches a height of 50 feet. So after 3 seconds, it's at 50 feet. What is that coordinate point? 350. Then it says it should land on the ground in 10 seconds. So after 10 seconds, it's on the ground. What height is the ground? So what is the coordinate point? 10, 0. So do we have 3 points? How many points do we need to create a quadratic? At least 3. A linear line needs 2. A quadratic needs at least 3. So now, what do we hit in our calculator? Nope. Stat, edit. Then in L1 goes our x values. So you put 0, 3, 10. And in L2 goes the y values in the same order. 45, 50, 0.
$45, $50, and
0. Then what do you hit?
stat,
Stat, calc,
Linreg,
not linreg,
quadreg.
quadreg. That's a quadratic. Then what do you do?
Are we gonna store it?
We are. We want to see it on the graph.
Alpha trace.
You hit alpha, not math. Crap. You hit alpha trace.
Oh,
Y1. You press enter.
oh no. Hold on, wait. After the table,
Alpha trace. And it should come up with Y1. And then enter, and it'll give you your equation, which we're going to write down. Y equals negative 0.88 x squared plus 4.31x plus 45.
Okay. After the table, I hit alpha trace.
No. So you go to stat,
Okay, yeah.
calc,
Okay.
5. Go down to store, and then you hit alpha trace.
I see.
And then calculate.
and then calculate.
Oh.
Then if you go into your y equals, it's stored it in y1 for you. Now notice, we were just working in our calculators, right? So is what's in y2 part of this problem?
Yes.
Negative 8 plus 15 is part of this problem that we're doing right now.
No.
Where was it from?
The last one.
The last problem. So what do you think we need to do with that?
Put it in the last one.
Clear it. Get it off of there. And what are we putting in instead?
The other one.
Yeah. 1.15x plus 30. So we're inputting this equation instead.
Oh.
Then it's the exact same process as before. Go to your graph. Oh, hey. Oh my gosh, that was quick. Thank you. Oh my, all these, wow. Ooh, and new ones.
Yeah, so I gave you a bunch in case somebody else
Great.
needs something
Yes.
to share.
Perfect.
Do you know which calculators need to be
Yes.
updated?
These two.
All right, and then do you have one that's working or that
Yes.
has the operating system you want?
This one.
All right, cool. I will see if I can figure it out.
Okay.
I did it.
You didn't, thank you so much. Like, I could have figured this out. My
That's
husband
okay.
says that, or my husband, Nick says that I'm getting worse at technology because he's so good.
Yeah, right. So you just let
Yeah.
him do stuff. Where did I put that cable? I thought I had a cable. I had two in my. Here's the other one.
So,
Sorry.
can I see both intersection points? Can you see both intersection points? Okay, what do you do? Okay,
Or window.
go to Zoom, and you can try Zoom Fit if you want, or look at the graph. Where do you want this graph to go? We're missing what part of the graph? The top. So what do I need to increase? Naya, what do you think I need to increase?
Let's see, the Y max?
Yes.
Boom.
You go to window, and Y max you make bigger. I'm gonna make mine 60.
So the bag will change.
Not right now. Oh my gosh, Roman. All right, are both of these intersection points plausible? Are they reasonable? Do both of these intersection points make sense to us?
Yes.
Why? Look at them. What does X represent? What does the X-axis represent?
Seconds.
Seconds, time. So do both of those intersection points make sense? Why not?
Oh, it's negative.
Oh, what cannot you have?
Negative.
Negative what?
A negative X.
Yes. So, how do I find that positive intersection point?
Second trace.
Second trace, then what?
Intersect.
Good. Then what? What do you hit next? Enter, enter, and then? No. No, 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 no. Do you hit enter 3 times? Why not?
Because it.
If you hit enter 3 times, what could you accidentally end up with? If I hit enter 3 times, how many intersections are shown here? 2. Are both of them reasonable?
No.
No. If I hit enter 3 times, what could it give me? The negative. What do we want?
The
Positive. Get over to the positive intersection and then press enter again. My gosh, we're almost done. You guys are all of a sudden super dead.
It's because I came in.
Right? No. Okay. So we have 6.29. And what's our unit? Seconds. And then we have 37.24. And what's our unit? Oh my gosh, we're done.